Okay, we're going to review the most important problems for your test. And this one is f of g of x and, f of x and g of x. And we are going to prove that those are inverses. So I want you to make the f function eat the g function, and that should simplify all the way down to x. And then do the other part, which is just the reverse. And make sure it simplifies down to x. This one is all about showing the work, and some of you guys are not great at showing work. I'm telling you, you need to show your work on this really, really well. Because if all you say is like a bunch of junk and then it says x, if it's not clear what your work is, it's going to get marked wrong. So f of g of x, here's the f function. I'm putting in 4 parentheses where the x was, and then I'm going to drop in this function in there. X plus 7 over 4. Now you have to know what can cancel first. The kid who cancels the 7 first gets this problem marked wrong, because that 4 and that 4 can cancel first. Then you need to have one step of simplifying it, and then you can say it equals x. And then the other way, g of f of x, and that's where you take the g function here. Empty spot, I didn't make it big enough. I got to put something in there. Empty spot plus 7 over 4. See how that's just that? And now it's going to eat the other function, which is right here. And that goes in there. 4x minus 7. Did you know that the 7 canceled first? I hope you did. And then did you simplify it to say 4x over x, over 4, and I'd be looking for that. And then I'd be looking for the answer of x at the end. You guys feel like you understand how to prove two things are inverses? All right, yes?
Can you prove that they're inverses by taking the y and the x and flipping them?
Nope, that's creating an inverse. That's on the test too though, so let's practice one of those. 4x minus 10. If that's your function, find its inverse. But there's certain things that are allowed for proving, and there's certain things that are allowed for just making an inverse. This process is not a proof. Just like in court, there's certain things that can be allowed for evidence, and there's certain things that can't. Even though it might seem very compelling that the guy admitted that he did the crime, if he wasn't read his rights, you won't be able to use that evidence. You know, there's certain rules for proving is my point. All right, so this has an inverse. X equals 4y minus 10. Add 10 to both sides. Divide by 4. And that is your inverse. And if you just kind of look and say, oh, it's got minus 10. This is a plus 10. It's got times 4. This one has a divide 4. It'll sort of make sense, I hope. I really need to get a gauge for how many of you are getting these. How many of you had this exact thing? X plus 10 over 4. Okay, good. Thank you. So what else is on this test? There's a different kind of proving on this test, and that has to do with proving things are odd or even. First off, if you knew that something was odd, and I didn't tell you this side, but I told you that I had this funky looking thing on the right side, and that this point right here was at 5, 3. If you knew this thing was odd, you should know what the picture looks like over here, and you should be able to tell me what point has to be on this thing. So, you know, you got to imagine like I'm doing it wrong on purpose. You got to imagine like, oh, it's over here, and therefore this point must be on it. Take a second and figure out, there's even kind and there's odd kind. What point has to be on this function? If 5, 3 is on it, what other point has to be on it that's over here somewhere? So write it on your paper, something comma something must be on it. And then I want you to compare with the kid next to you, and you guys might have different answers, and some of you might be lost. Talk it through with the kid sitting next to you. Okay, here we go. Odd ones go like that. You know, like if I draw the big picture of it, and this one was going like this, the rest of it would go like that. And that's how odd ones work. So the other point had to be down here, and it should have been the point -5, -3. Now, how do you know? Well, on odd ones, do you remember the rule is you put in the opposite of x, and on an odd one, you get the opposite of the y. F of x is y. That's what this means. Put in the opposite of x, you'll get the opposite y value. So here we put in the opposite of x and we get the opposite y value. So -5, -3. Okay. So how about proving things are odd or even? Here's one. I think that this might be odd because it's got this power right here. I'd like you to prove that this is either odd or that it's not odd. Alex K. What's the first step?
Change the x to a -x.
Excellent. We put in a -x. Now, on the other side, wherever there was an x, I'm putting parentheses. I hope you guys did too, because those parentheses definitely matter. Trent, what am I sticking in the parentheses? Correct. So that's step one. You just stick in a -x. Dominic, this line right here is just simplifying everything. Can you tell me what it simplifies to? -4x to the third. The negative stayed. Minus 2x. The negative stayed again. Okay. Then the fourth line is the proof line. You're either going to write f of -x is equal to f of x, and let's just look at that for a second. Is this really exactly f of x? Is it? No, it's not exactly f of x. So I can prove right there it's not even, but that wasn't my goal. My goal was to prove that it was odd or not odd. So this is the proof line for odd. -1 f of x. Now look at it. Does it look like there was a 1 that got distributed, sorry, a -1 got distributed into this?
Yeah.
I agree. So this thing's odd. That make sense to you guys? Okay, that's called proving that a function is odd. All right. What else is on this test? A whole lot of this. F of x equals 2x plus 5. G of x is x minus 7. You got to do a whole bunch of like add, subtract, multiply, and divide them. So I'd like you to try f plus g of x. F minus g, I'll warn you, that's one where people get wrong a lot because they screw up the parentheses. F times g and f divided by g. Everybody take a second and do all of those things. F plus, f minus g, f times g, and f divided by g. I'll pause for a second while you try that. Okay, Anna, I'm going to pick on you this time. When you add them, you just take this and add that. What do you think you get?
3x minus 2.
Correct. The minus one is more tricky. Tell me what happens on the minus one that would sometimes trip people up. Anna?
That would trip people up.
Yeah, what do they do wrong on this one?
Distributed?
Yes, that has to get distributed. So then, what's the final answer on that one?
I didn't finish that one.
Okay, let's do it together. 2x and the minus x.
Just act.
Yep, and the 5. And keep in mind that's negative 7, so 5 plus 7. That's what everybody messes up. 5. And this negative has to hit that negative 7, so this becomes positive 7 and positive 5 for a grand total of,
Plus 2.
nope, we're talking 5 plus 7. 12. I can see why people get that one wrong. If we had that much trouble right here with me in class. So be careful on that. What I would do is distribute that all out like this. 2x plus 5 doesn't need any distributing. Minus x plus 7. If you distribute this negative out, you'll get that. And then most of you will put the 5 and the 7 together and make 12, and it'll be no big deal. Okay, the times one. Dominic, you're on deck for the times one. We're going to multiply 2x plus 5 and x minus 7. Tell me what you got, or we'll do it together right now.
Distribute first.
Okay, so we're distributing like this, if that's what you mean. This is that first outside, inside, last thing. So, what do we get?
2x minus 14x plus 5.
Okay, 2x times the x. What's 2x times the x?
2x.
No. 2x times
Oh,
x.
2x squared.
There we go. Okay, now we're taking the 2x times the negative 7. What's that?
Negative 14x.
Correct. Now we're taking the 5 times the x.
Minus.
And last,
Minus 2.
we're multiplying.
Oh, yeah.
Negative
Negative 35.
35. There we go. All right. And those two together minus, let me think. I think it's minus 9x. Can anybody verify that?
Yeah.
Got a minus 9? Okay, good. That was the two functions times each other. And the last kind, divide them. 2x plus 5 over x minus 7. And if you can factor it, you should, but there's nothing that can factor here. So then there's nothing that can cancel, so then you're done. Weirdly, divide way easier than multiply because you can't really do anything. Okay. Now, this one, we're going to do f eats g of x. And then we're going to figure out its domain. So what's f of g of x? And it's, oh wait, I'm wrong. Hold on. I want to do the other way around. G eats f. And I want to change something. Dang, double oops. This would just be a little too tricky. So change it to minus 4. Okay, so I get x squared minus 4 and 1 over x, and we're going to do g of f of x. Everybody give that a shot. I'm going to pause where you make the one function eat the other function, and then the domain. Hint, remember that whatever the parent's weaknesses were also are going to come in and be a weakness for the kid. A lot of times that means there's 3 different weaknesses. I'll pause for a second while you give this one a try. Okay, Sophia this time. Each of these has a domain, like what they're allowed to safely feed that function. What was the domain of the f function, Sophia? All real numbers. Good. Or you could say negative infinity, positive infinity with a comma and parentheses. Ethan T, what's the g's domain. What can you safely feed the g function?
I just drew a number line and it can't be 0.
I agree, that's exactly right. Can't be 0. And that's what I did too. I don't like to write it out with interval. You can write interval if you guys really like it. I like a number line. Especially because at the end, we need to make one big number line that includes all 3 parts. Mason, can you tell me what happened when G8F?
You,
Here's the G.
you put x squared minus 4 into the parentheses.
Yep. Did you remember to factor it?
Yeah.
Excellent. What did you factor?
X plus 2, x minus, or
Yep,
x
you're right.
minus 2.
Good job. Okay, now this is my new function. And you can see its weaknesses. Rissy, what are the 2 weaknesses of my new function? Can't be -2, and it can't be 2. Empty spot, empty spot. And a lot of kids are going to have this answer on their test, and I will have to cry a little bit and mark it wrong. Brady, what are they forgetting?
0.
Yeah, you have to include that parent weakness for the 0. So I'm going to put it in here. Another empty spot at 0. Because you have your own weaknesses, and you also might have the weakness of your parent, like a tendency towards some hereditary thing. All right, cool. That's not everything, but that's a lot of things that you have to know for the test. And I just want to end with a chance. Look at the review worksheet. Is there anyone on there that is absolutely kicking your butt and you'd like to talk over? Like, I really don't get this kind, Mr. Server. And if you just read me like it's problem number 6 or whatever, I'd be happy to help you with it. All right, then I'm going to include one that I know you guys need to know and we haven't talked about yet. And that is vertical and horizontal asymptotes. And I hope you know the difference. Horizontal ones go like this and they set a limit of how high you can go. Okay, vertical asymptotes are like this and they come from the denominator. X squared minus 5x minus 6 over x squared minus 2. Nope. 4. Sorry. Figure out the horizontal and the vertical asymptotes of that puppy. Remember that you need to factor it before you do the 1,000 trick. Now, some kids are going to forget, well, I wrote 7, but it has to be like x equals 7. Don't forget those. You will get it marked wrong on the test. You can't just say like 7 for an asymptote. It's got to be an x equals or a y equals, and you have to know which ones are which. The y equals ones are the horizontals. X ones are the verticals. All right, first job is the factoring. Addie, can you do the factoring for me?
The top one is x plus 1 and x minus 1.
Yep,
And then the bottom one, it's x plus 2 and x plus 2.
very good. All right. Arrow, can you tell me either the verticals or the horizontals, whichever you'd rather?
The vertical asymptotes is x equals plus or minus 2.
Yes. Vertical x equals plus and x equals minus 2. Make sure you list them separately like this because it is two separate asymptotes. Okay? Dominic, the horizontals. That's the kind where we're going to see what happens if we go way over here. So like you put in 1,000 and you see if it like goes up forever or if it stops, levels off somewhere. What do you say? Okay, so I'm going to put in the 1,000 and you tell me how to like interpret this. Act like I'm your little brother who's just learning how to do this. I put 1,000 here, 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 and here. What do I do?
Cancel out the pluses and minuses.
Okay, because they don't really matter. All right, and now it's 1,000 times 1,000 over 1,000 times 1,000, and what can happen to those thousands? Yeah, this just turns into 1, this just turns into 1, so the answer is 1. But you got to be careful. That is y equals 1. See that? That's how I know it's a y equals thing. There we go. All right. So, I hope that you will use this anchor time now that you're about to have to good effect to get this worksheet all the way done. Maybe you'll feel completely ready for this test. If you have questions, perfect time for anchor time for you guys because you can come up and ask me. That's all I got for the video for today.